In the next three videos, starting from this particular one, we'll be looking at some applications of surds. And I mean, these are well-known applications if you are a math student already. So in this one, we'll be looking at surds in Pythagoras theorem. So we come across surds in Pythagoras theorem a lot. So that in fact, this is one of the earliest breakthroughs in mathematics, the Pythagoras theorem. Okay. So, Surds and Pythagoras theorem, the topics we are to consider here will include things like finding exact lengths, leaving answers in surd form, simplifying square roots. This lesson explains how Pythagoras theorem produces surds and how to leave answers in exact form instead of decimals. I mean, we've talked about that a bit in the last video. So, question again, what is a surd? Of course, in case this is your first video, and you've not seen previous videos, I think it's always important to reiterate the idea of a surd. So a surd is a root, usually a square root, that cannot be simplified into a rational number. So, I mean, if you have square root of 4, that is 2, and 2 can be represented, it can be written as the ratio of two integers. That's what a rational number is. So 2 is 2 over 1. So 2 is integer, 1 is integer, so 2 over 1. So, and that's why you call that a rational number. But if you have square root of 2, you cannot write it like in that form. So that's why root 2 is a surd, root 5 is a surd, 3 root 7 is a surd because you cannot write root 7 as a rational number. Root 3 over 2 is also a surd. These values cannot be written exactly as terminating or repeating decimal, so we leave them in root form. So example, square root of 3 is 1.4142135. So it is not terminating and it is not repeating. So the decimal never ends, so the exact value is written as a surd. So we better leave it as root 2 to preserve the value. So simplifying surd, of course, we've done that a couple of times. So many square roots can be simplified by factorizing the number inside the root. For instance, square root of 8, you look for the biggest square roots, the biggest square that is a factor of it, that is 4. So 8 is 4 times 2. So square root of 8 is square root of 4 times 2. That will be square root of 4 times square root of 2, which square root of 4 is 2. So square root of 8 is 2 root 2. You have the same kind of thing with square root of 50. For square root of 50, the biggest square roots, that is a factor of the biggest square rather, that is a factor of 50 is 25. So 50 is 25 times 2. So square root of 50 is square root of 25 times 2, and square root of 25 is 5, then root 2. So we go on to have Pythagoras theorem. So Pythagoras theorem applies to right-angled triangles. Okay, this is the idea. You have a right-angled triangle is a triangle that has angle in which one of the angles is right, meaning you have a perfect angle. That's an angle of 90 degrees. And whenever you have this, this kind of triangle, so the side facing that angle 90 is called the hypotenuse. It's usually the longest side. And then you have two other sides called adjacent sides. So this side is adjacent. This is also adjacent. So the two of them are adjacent to themselves, right? This is another adjacent side. But by the time we get into the idea of trigonometry, right? So we can now distinguish between the two adjacent sides, which one is opposite and which one is adjacent to the opposite, right? But generally speaking, what Pythagoras theorem teaches us is that when you have this, right, the so Pythagoras theorem tells us. Okay, I guess I want to take this down. Okay, Pythagoras theorem tells us, according to Pythagoras theorem, according to the Pythagoras, by the way, Pythagoras was one of the earliest mathematicians, a Greek. Uh, According to the Pythagoras theorem, okay, we have this thing that the square, according to the Pythagoras, maybe I should write it in words first. The square of the hypotenuse, the square of the hypotenuse is equal to the sum to the sum of the squares to the sum of the squares of the adjacent sides of the adjacent sides. So in essence, if we have a right angle triangle. I mean, it can come in any form. It doesn't have to be exactly like this. I can have it like this, okay? And this angle is right. So this is hypotenuse. So let's say this is A, this is B, and the hypotenuse is C. Okay. So it's this rule is simply telling us that C squared is equal to A squared plus B squared. That's all Pythagoras is telling us. And that makes sense, you know. It's well proven. So the formula is a squared plus b squared equals c squared, where a and b are the shorter sides, which I call the adjacent sides, and c is the hypotenuse, which is the longest side. So the hypotenuse is always opposite the right angle, right? So if we want the hypotenuse, we can say c is square root of a squared plus b squared, and that's exactly what we have here now. So if you're looking for just c, so you can say c is, take the square root of both sides. So c is square root of a squared plus b squared. And that's what the hypotenuse looks like. So this can end up being a surd depending on the situation you are dealing with. Okay. So with that now, we can talk about finding exact lengths. So finding exact lengths, when we solve Pythagoras theorem, we often get square roots. If the result is not a perfect square, we leave the answer as a surd. So example, imagine you have sides A is 5, B is 7, right? Something like this. So you have this now. So this is the big angle. So you have A here to be 5 and B here is 7. So we are looking for C. Okay, so what we just do is we know C squared is 5 squared plus 7 squared. So C squared is 25 plus 49. And then C squared is 74 when you add all that. So C is root 74. Root 74 cannot be simplified, and it doesn't have it's not a perfect square. So we just leave it like that to preserve its value. So that's exactly what happens here. So since 74 is not a perfect square, the exact answer is root 74. Then we move on to talk about perfect square results. We can have cases where this the values this the hypotenuse ends up being the square root of a perfect square, and then you can have a rational result. So find the hypotenuse when a is 3 and b is 4. So c squared is 3 squared plus 4 squared. So c squared is 9 plus 16. C squared is 25. C is square root of 25 and c is 5. This is not a surd because 25 is a perfect square. So that happens. Then we can also have surd results that require simplification. So imagine you want to find the hypotenuse when A is 6 and B is 10. So C squared is 6 squared plus 10 squared. Then that means C squared is 36 plus 100, right? And then that means that we have c squared to be 136. And step 2 now, c is square root of 136. And you know, 136 may be looking like a number you're not familiar with. So in case you are not even sure, you can get a perfect square out of it. So one of the previous videos, I already talked about the factor tree. So you can always use the factor tree to be sure that you can get a perfect square out of it. So you have 136. 2 in 136 is that is 67, I believe. 6 in 2 in 13 is 6. Then not 67, in fact. 2 in 13, that's 12, that's 6. Remember one, 2 in 8, 2 in 16 is 8. Then you have 2 again. 2 in 68 is 7 is 34. Okay. Then 2 in 34 is 17, and 17 can go one time. So here we see that 136 is equal to 2 times 2 times 2 times 17. And since we are talking about square roots, you want to group them into twos. You want to see numbers that can appear into. So you have 2 raised by 2 times 2 times 17. So this is clearly a perfect square. So that means you have 4 times 34, you know. So that's what happens there. So 136 can be broken into 4 times 34 because it's the biggest perfect square you can get out of it. So that means 2 roots 34. So your final answer is simply 2 roots 34. And you leave it like that to preserve the answer. So 18.7, finding a missing shorter side. What if you have the hypotenuse on one other side and you need the remaining side? Sometimes the hypotenuse is known. So imagine hypotenuse is 13 and the other side is one side is b equals 5. So to find a now, so you have a squared plus b squared equals 15 squared. Okay, I mean, what we're saying here is this. You have 13, 5, right? So that you have imagine that you have the perfect square now is like this. So this is now 13. And then you have, say this is 5, you know, that B is 5 now. This is your C. And you're looking for A. What is A? So we know that here, C squared is equal to A squared plus B squared, according to Pythagoras theorem. So that means 13 squared is equal to A squared plus 5 squared. So that means 13 squared is equal to A squared plus 25. Okay, 13 squared, of course, we know 13 squared is 169. Okay, so that means we have 169 minus 25 equals A squared. So we can say A squared now is equal to 144. So A is square root of 144. If you take square root of both sides, so A is simply 12 here now. Okay, A is 12. So that means that other side is 12. Okay, so that's what exactly we have right there. So if you have the hypotenuse on one side, and you can look for the other side. Now we can also have missing side with a surd. So imagine now that you have the hypotenuse to be C equals 13 and B is 9. So again, of course, you know that's A squared plus 9 squared equals 13 squared. That's A squared plus 81 equals 169 because 9 squared is 81, right? And 13 squared is 169. So A squared is 169 minus 81. So that's A squared equals 88. Okay. And from 88, it's easy to see that the biggest perfect square is 4, you know. So 88 is 4 times 22. So square root of 88 is square root of 4 times square root of 22. That's 2 roots 22. And you have 2 roots 22 as the answer there. Then sometimes you have special triangles. So imagine you have a special triangle. In an isosceles triangle, the two shorter sides are equal, right? In an isosceles triangle, the two shorter sides are equal. So, I mean, we're talking about an isosceles right triangle. That is, okay. Imagine you have an isosceles right triangle. So you have this triangle, this is the right angle, but this side is equal to this side. So in that case, if we take those two short sides to be 1 unit each, so if A is 1 and B is 1, you know, I think we talked, this is one of the first things we came across. We did it for a number line, right? So this is 1, this is also 1. So we now need our C. So we know C squared is 1 squared plus 1 squared, because this is now A and this is B. Because it's an isosceles right triangle, so we have C squared equals 1 plus 1. So C squared is 2. So C is equal to square root of 2 like that. So C is root 2 in that case. Okay. So the rule is if the shorter sides are x, the hypotenuse is x root 2, generally speaking. So if the shorter sides are x, then the hypotenuse is x root 2, because the shorter sides are 1. So it means we have, 1 root 2. That's why we have root 2 here. So example now, if x is 5 now, so imagine if instead of 1 here, we had 5, okay? So what is this is simply telling us that if we had uh isosceles right angle triangle, so if this is 5, A is 5 and B is also 5, and we're looking for C, so C squared is equal to 5 squared plus 5 squared. So C squared is equal to 25 plus 25. So C squared is 50. So C is square root of 50. So the biggest square root, which is the biggest square that is a factor of 50, is 25. So that's square root of 25 times 2. So C is equal to square root of 25, that's 5 root 2. So for an isosceles right angle triangle, whatever the smaller sides are, the value of the big side will just be that value of a small side multiplied by root 2, basically. Okay. So we have that. Because for 1 unit, it's root 2. For 5 units, that'll be 5 root 2. So why do we leave our answers in short form? That's another a big question to answer. Example, you have square root of 2. Decimal approximation is root 2, which is approximately 1.414. However, the decimal continues forever, right? It just keeps going. It is non-terminating and it is it doesn't repeat. So using sorts, you keep exact values, you avoid rounding errors, and it is required in algebra and geometry to leave your answers in sort form. So that's an elegant way to leave your answers. So if you have exact to be square root of 74, but the approximate is 8.60. So the exact answer is actually the surd, which is more preferable. So we have common sort simplifications like root 8, that's 2 root 2, because that's 4 times 2, right? So that's square root of 4 is 2, square root of 2 remains. Then root 12 is 4 times 3, square root of 4 is 2, root 3 remains. 9 times 2, square root of 9 is 3, root 2. 4 times 5, so square root of 4 is 2, root 5 remains. Root 50, that's 25 times 2. Square root of 50 is 25 is 5, and the 2 is left there. In summary, we have that you can use Pythagoras theorem, a squared plus b squared equals c squared. You can substitute the known side lengths and solve for the unknown side. Then you take the square root, simplify the sort if possible, leave answers in exact sort form unless a decimal is requested. So if you are required to do a decimal, then you can do that. If not, you can leave the answer in sort form. It's better like that. So it's time to answer questions here. So I'm just going to take 10 and 20 and just get going, right? So a right triangle has hypotenuse C is 20, one side B is 12. Find the other side, okay? 20, 12. Find the other side, okay? So here we have the hypotenuse 20, that's our C, and then B is 12, I believe. A is now what we are looking for. This is right angle. So A is what we are looking for. So this is a right angle. So now we know that this is A squared plus B squared equals C squared. So A is what we're looking for. B squared is 12 squared. C squared is 20 squared. So A squared is equal to, A squared, 12 squared is 144. And that's equal to 20 squared is 400, I believe. Yeah. Then A squared is 400 minus 144. So A squared is equal to what's that now? 400 minus 144. 400 minus 144. So 10, there's 6, 9, that's 5. So 3, that's 256, I believe. Yeah, I think it's 256. Yeah, it should be. So this is 256. So we have A now to be square root of 256. All right. I think square root of 256 is 16. So A is equal to 16. So, in fact, we have some numbers called Pythagorean triples, right? So I think A is 16 here. Let me just confirm that 12 squared plus 16 squared should be 400. If that gives 400, then we are good. So 12 squared plus 16 squared. Okay, that works. So it means 12, 16, and 20. If you numbers uh, that make up a Pythagoras. Okay, I think I want to just make mention of Pythagorean triples. So we have Pythagorean, Pythagorean, Pythagorean triples. So there are three whole numbers that make up the Pythagoras, that make up two adjacent sides and all that. So you have examples like 3, 4, 5, 3, 4, 5, 6, 8, 10, 6, 8, 10. Now we have okay, even multiples of these things can work. Okay, you can even see that this is a multiple of this, and we have seen that in even 12, 16, and 20. So this you can see this is like if we call this A, this is like 2A, and this is like 4A. They all work like that. So these are Pythagorean triples. I think another one that does not belong here is 5, 12, 13. Okay, 5, 12, 13, 13. Because square root, you have 25 plus 144, that's 169. That will give you this. So this doesn't belong to that class. But of course, we can take multiples of this and we also get other Pythagorean triples. Okay, so that's I've answered one question there. I've answered question 10. Let me just go for 20 and keep it moving. Um, okay, so here, well, I think I don't even have to worry about this. In a 45 degree, 90 triangle, each shorter side is 6. Find the hypotenuse. The hypotenuse will simply be 6 root 2. if each total side is 9, the hypotenuse will simply be 9 root 2. So we've established that already. So let me take question. Well, I think any question I take is fine. Let me just take question. Let me just pick anyone. Because this is pretty simple. Let me go for. Or I can just rest, right? I think it's good. We are good. Yeah. I think it's fine. They are pretty simple. So try your hands on the rest and let's be sure you really get the gist. Okay. Let me know how helpful all of this is for you. And if there's something else you have in the trial, feel free to let me know. If you have subscribed already, I thank you very much for subscribing. If you have not, go ahead, subscribe, hit the notification bell so that you can always get alerted each time a new video is released. Thank you so much for doing that. And of course, if you want to become a member of the channel, you can click on join. That gives you special privileges like getting to see some videos first or being the only one to see some videos because you're a member of the channel. You can also request for PDF copies of my notes. We can hang out together to discuss whatever interests you on my channel and all that. So there's a lot you have to learn from here. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing math right. Bye.